Hello guys, this is Imran Habib and I'm going to demonstrate you the game that I developed in my master's thesis. And so as some of you guys know that I have done masters in robotics and intelligent systems from Örebro University, Sweden. So in my master's thesis I had to develop a virtual reality based game. So I will show you what I did in my master's thesis through this video. I want to give you a little bit concept about the virtual reality on which my game is based on. So here the virtual reality is such a concept in which an illusion is created into your mind, and you feel like you have gone into the environment that's artificially created or simulated environment. What happens is that you stand inside a specific cave, which is a small room and is of a specific size, and there are screens on your four sides, and you observe and experience the environment by standing inside that cave, and you feel like that you have gone into the artificially created environment. Just imagine that you are this specific agent that's roaming around in this environment, and whatever this girl is observing, so you will observe the same things around you in 3D. So as you have four screens on your four sides, so you feel like that you have all the things that are, so these four screens will have the data that the agents are observing on their four sides. So what we do is that we get the information through sensors from your body. For now we are using only two sensors. One kind of sensors are in your foot, and the other kind of sensor are in your hand. The sensors that are in your foot, they record the movement of your walking, and then we transfer that movement that's captured from your foot, and then we transfer it to this guy, your avatar. And similarly, the card that you are holding inside while standing inside the cave, we take that information and use it for turning of your avatar. So in fact, this avatar, you will interact with the agents, with the objects in this 3D virtual world through your avatar. So the information is obtained from you and is given to your avatar, and then you interact with these agents and obstacles and objects through your avatar. So I will show you now the game, the functionality that I implemented in this game. So now you can see some of the agents that are walking around, and you are seeing that there are some girls who are walking on positionless, and they are avoiding each other. That I will tell you in detail. And there are some guys standing there. So one of those guys is a keyboard controlled agent that will be later replaced with a sensor agent. I mean, that will be controlled through the sensors. For now he is being controlled with the keyboard. So I show you the first thing that I got from for the camera control. We press I for moving the camera, for sliding the camera in the forward direction, and we move K for moving it to the backward direction, for sliding it backward. So we move J for moving it to the leftwards, and L for moving it to the rightwards. So similarly, we can roam around using these keys, but we need a rotation. So for rotation, I use the O key. I give the information to the O key that if someone presses O key, so you have to move, you have to rotate around on your own axis. So right now I'm moving O and L, so it's sliding plus rotating as well. So I'm just doing it to show you the environment that I've created here. So this is just kind of a spectator view that you can use to roam around in the whole environment. So before going into the details of the other functionality, of complex functionalities, I will show you a little bit the environment that I have created here. So you can see there, this is actually the Moose floor, one of the campuses of Örebro University, named as Alfred Nobel campus, and it's in Karlskoga, Sweden. So I will go through this. Yeah. So this is the this is the third floor, only one floors of that specific campus. So I'm using the camera keys for controlling. This is the corridor. There are 3 labs, a toilet, elevator as well, but for now I'll show you the lab, the cave lab where we are supposed to be in. So here you can see that this is the cave lab, and this is the cave model, and what you see is that there are, for now you are seeing just a model. So in real life there is it's same this cave which is also present there. So these gray colored boxes are the screens in real life, and you experience the virtual environment when this specific virtual environment is projected onto these screens. So for when you will stand inside this cave, what happens is that if you are walking through this virtual environment, so you will see, for example, on your right screen something that's on your right. Whatever is here you will see on your right screen. So whatever is on your left, for example this table, so you will see it on your left screen. Similarly, in front of you will see something that's in front of you, and so on for the back also. So this is the model, but in real life there is a cave as well, so where you experience this virtual environment. I hope you have got the idea what happens when you experience a 3D virtual environment. So you can see this guy, he's moving from one position to the other position crazily, and he's supposed to move on this position list, and he's supposed to interact and observe the presence of the keyboard controlled agent that I will show you later. For now, first of all, I want to show you the obstacle avoidance that I implemented in this. So you can see here what happens is that in real life we guys know that when there's an obstacle in front of us or a table in front of us, so we have to avoid it and we don't have to collide it. But these agents don't know that if they have an obstacle in front of them, so if they should collide with that, or if they should go through it, or if they should do what. So we have to build such an intelligence in them that if you have an obstacle in front of you, a table, a chair, or whatever, a box or whatever, so you have to turn around it. You have to turn away from it and go around it, not go through it, not collide with it. So this is what this agent is doing, that it's going around it and it's not colliding with it. Although it was supposed to move through this path, because his path is decided in such a way that it's through this box, but as this box is supposed to be avoided, so we told this agent to avoid this obstacle and don't collide with it. So the next thing that I want to show you is that how we implemented the agent collision avoidance in real life. As you know that human beings know that they have to avoid each other, so but these agents don't know that if they have to avoid each other or do what. So when they come across each other, so what they do is that they don't collide with each other. So they go away from each other and don't collide, although their path is supposed to be the same that they are moving on. You will see that they will come across each other, and then one of them goes away from her. So as soon as she sees that there is a girl in front of me, so she goes away from her. So you will see this other girl, she was going straight on the path, and she avoided the obstacle, and so she went away and she didn't collide with it. I will show you later again this obstacle avoidance of this specific girl, as she has gone, so she has to complete her trip. So she will, when she comes back, I will show you this. For now, you can see this guy, interaction with this guy, or rather I think maybe she's going back now, so it's better that we go and follow her first and see what she is going to do here when she sees an obstacle in front of her. So all the agents are supposed to avoid the obstacles that are inside the environment. So you will see her that she is going to avoid this obstacle and will not collide with it, and rather go around it. So you can see here, so she went around it and then she starts moving away. Okay, so I show you the cool agents interaction, how agents interact. For now you will see that he's outside the range of this guy, so the guy who is running, he will not observe him, he will not observe his presence. So as soon as I come inside the range, so this guy will observe this standing guy. Running guy will observe the standing guy. Yeah, you have seen that he's looking at him, and unless he's in his range, he will keep on looking at him. So I will show you more closer a bit. Yeah, so now you will get a more better idea than what I'm trying to tell you. So you will see that as soon as he sees him, he looks at his face and then he keeps on looking at him unless he's in a specific range. Now I show you another interaction which is supposed to be with the standing guy. So what I do is that I will go closer to him and he will say something to me. Okay, now so here we go closer to him. I take the camera closer to him first. Okay, so now you will see that as soon as he sees him or observes his presence closer to him, so he will start looking at him. For now he's away from him. Yeah, you have seen that he has started looking at him and started giving a posture. So as soon as he goes away, so he stops looking at him. You will see now that he stops looking at him. Yeah, okay, so wherever he's going, wherever he goes, so he starts looking at him and he keeps on looking at him unless he's in a specific range. Okay, so now he's closer to him, he's observing him, and now he's not observing him. He's not observing as he's outside the range. So as soon as he comes inside the range, so he starts observing again. He goes out, he stops. So wherever he will go, he will keep following him unless he is in his range. So this is what I did in my master's thesis. This is the project that I did, and so that's what I wanted to show you. So in summarized words, I want to tell you that what I did is that I created each and every single wall in 3D Max. Then I exported those objects, all the walls, all the tables and everything, and then I converted them with a Collada converter. And after converting them, I create a mousse floor that you can see here, this big floor. Yeah, so by joining each and every single wall and objects, all the objects that are inside the environment. So after creating this in the Hudi 3D scene editor, I get the XML generated from that specific, so that I can access so that I have the scene graph, proper scene graph in that XML, and I can access in each and every wall, object and tables and everything through that XML. Through that specific scene graph. Then I integrate that XML with my game engine code, and I integrate all the agents with it, and I integrate my autonomously behaving agents and the keyboard controlled agents. And so the keyboard controlled agent is later replaced with the sensor controls, and that's actually the avatar, in fact the avatar of you, and he behaves whatever you do. For now it's only 2 sensors, the accelerometer for your walking movements, for capturing your walking movements, and the game track game system sensor for the direction control. So I hope what you have got an idea what I have implemented in this game, and what I have tried to give you, and it's the real-time interaction with a 3D virtual wall, whatever I told you up till now. Thank you so much for watching this video. Yeah.